Hello everyone, I hope you guys are doing very good. Today I'm back with a new video that is called saponification reaction. That means if you have the ester, how to make the carboxylic acid. So in this video I'll show a couple of reactions and choice of method, what are the base or like solvent you are going to use for that process, and also I'll show the mechanism of the saponification or like ester to carboxylic acid reaction. Let's see what are the reactions I'm talking about. So if you have ester, so this ester, if you want to make the carboxylic acid from this, so this carboxylic acid, so you can simply use sodium hydroxide as a base and methanol and water 3:1. So you can write sodium hydroxide, normally 10 equivalent, and methanol, water 3:1. So you will get the clean product of this carboxylic acid. So these kind of reactions you can also use other base like potassium hydroxide, but mostly people use sodium hydroxide and methanol and water. In some cases, if your compound is not soluble in methanol, so you can use THF, so THF and water. So then you should get the carboxylic acid. What is the purpose of this molecule, making of this molecule? So now if you add the acid like sulfuric acid here, so that that will cyclized here, so ultimately you can get the compound like this. So this is very common reaction in the literature. You will find many of the reactions like that, like having the carboxylic acid in the ring and ester in the ring, and probably you can design with the ester because to move with the different multiple step synthesis with the ester, it is easy, and once you make it carboxylic acid, it will give you like paint to purify, or like it will soluble in the water or something like this. So that's why made the ester, and at the end whatever you desired product at the end, make the carboxylic acid with the saponification reaction. So it will be this like this carboxylic acid, and after that move on with your desire, like what you want to do the carboxylic acid. So this is one example for this kind of carboxylic acid. So I have done this reaction, it is very clean shot. So you can do this, try this reaction if you have anything like this similar. Okay, so another reaction is I have also done. If you see my previous video on Shonogashira coupling, in that video I have given one reference paper, so maybe you can see their papers, and this oxygen is connected with any alkyl group. So even with the PEG, like polyethylene glycol chain or PEG chain, so or kind of ether, and if you have this ester, so the same method, sodium hydroxide 10 equivalent in aqueous solution, and methanol, water 3:1, and reflux. Definitely you have to do reflux. Previous reaction what I showed, there is also reflux, like 65 to 70 degrees Celsius temperature heating like 12 hours or overnight. So it will give you this carboxylic acid. So in both sides it will give you this carboxylic acid. So this is the product. There are many other reactions I can show. So almost in many cases you can use simply this reaction, sodium hydroxide, methanol, water 3:1, do the reflux, you'll get this product. So but there's sometimes some functional group present in the compound, then you have to be a little bit careful. So if I have this compound, like suppose nitro group and ester group, similar type of compound, but nitro group and ester group. So in that case, do not use the sodium hydroxide, use lithium hydroxide, 1 molar, and in methanol only. 1 molar solution, aqueous solution, 1 molar aqueous solution and methanol, and do the reflux. So you will get the carboxylic acid. In case of nitro group and also having the triple bond, I don't think triple bond will be the problem, but nitro group sometimes with a strong base can create problem. So that's why use lithium hydroxide. It is very selective for this reaction, and you will get the pure product like more than 97% yield. In some cases, if you have some other functional group or like amine type group, then you have to be more careful. Suppose if you have a compound like aryl group and something like this, and amine group, and somewhere, anywhere like in this molecule, that case you have to do like this ester group, like can be either the aromatic ring or like somewhere in this cyclohexyl ring or any aliphatic region. Like suppose you have this or maybe you can make bigger chain, suppose 1 carbon, another carbon, another carbon, another carbon, and make maybe here the ester. So in that case, I'll use very tiny amount of the sodium hydroxide, like 1 molar sodium hydroxide, maybe 40 to 80 microliter, depends on scale. So 1 molar sodium hydroxide and that microliter in THF and 0 degrees Celsius overnight. And so you have to maintain the temperature 0 degrees Celsius. That is the important thing for this kind of reactions when you have the amine versus the ester, because this once this ester form the carboxylic acid, that can react with the amine, or like somehow it can be problematic, like it will not be clean shot. But if you do like this continuous 0 degrees Celsius overnight, or like 20 hours or like 16 hours, so this will give you the clean carboxylic acid. When you have the carboxylic acid and also amine group, so it will be acting like a amino acid type things, like you have to adjust the pH to get your product with extraction. So like amine, it prefer base, like if you use extra base, so amine will be free, but produced carboxylic acid, that carboxylic acid will be salt. But if you use more acid, like then acid will be free, so acid will be H, but where the amine will also be positively charged. So in both cases, like it could be like water soluble, the positive charge amine like in excess acid, or negative charge in excess base for the carboxylic group. So you have to be very tricky to do the extraction. Normally what I do, I try to make adjust the pH around 7 by adding slowly acid or base, and then I do extraction with ethyl acetate, adding like 1 to 2% methanol ethyl acetate. So it takes a lot of time, like many times you have to do extraction, but still you can get maximum recovery from these kind of reactions and from these kind of products. So let's see the mechanism how this reaction happen. So suppose you have ester here, and first step is, if you use the base like sodium hydroxide, so it is a strong base, and see you already know the carbonyl group, so it is delta negative and this carbon is delta positive. So this electron, it is a nucleophile, so it will attack this carbon, that is called nucleophilic attack. So after that it will go there, then it will form these and this hydroxyl group and this group. Okay, so in next step, removal of this leaving group. that will be a leaving group. So this oxygen electron, if you want to show like this, so this one pair of electron will come back here and it will break down like from there. So in that case it will be this OH plus this electron will be taken by this oxygen, so R prime negative. Okay, and normally I can draw this hydrogen here. So normally this alkoxide doesn't stay like that, so this alkoxide will take this proton out, and ultimately the product will be O minus plus that alcohol product. Now once you make the carboxylic acid, this saponification reaction, so you have to acidify the reaction, because if you do, like if you don't have amine or any other group, like just you have the carboxylic acid group, so you just acidify. So in case of acidification, so that part will take, so if I go up here from there, so in presence of acid, your carboxylic acid will be like this, and it will give you the alcohol. And when you do the extraction and rotary evaporation, then you will get your carboxylic product, and maybe the alcohol will be gone with the solvent. Definitely R could be aromatic ring or any other things. So this is the mechanism, very simple mechanism, and it is called saponification. Also sometimes people use acid to do the saponification. Why this name is saponification? Because the soap, the people use the soap, that soap is actually made from the ester, triglyceride ester, like fatty ester or something, by using the sodium hydroxide, similar mechanism. And then that form the salt, like acid, like long chain aliphatic long chain with the acid group, and the glycerin as a side product like alcohol, that part is the glycerin. And that carboxylic acid, long chain carboxylic acid, react with the sodium hydroxide to form the sodium salt of it. And since that process is the same as this deesterification, like I shouldn't say deesterification, like ester to carboxylic acid, and that's why similar, and that's why it is called saponification. That means you can make the soap from the same reaction. Okay, today that's it, and I'm going to show a short video how to set up the reaction, like a small scale. So I'm setting a small scale reaction in a vial, so you can see how I'm setting that reaction, and how I'm maintaining the temperature, and where I'm putting the reaction set. So if you have any question, just ask me. I'll happy to answer. So here I have measured out my ester in a vial, and now I am putting a parafilm on the side of this cap, so that no water or anything can go inside this vial. And the cap should have a rubber septa, so I also put a magnet for steering. So initially I will put in the ice, and then I'm going to use normal regular THF. That should be pure, but not it is not dry or anhydrous THF, because since I'm going to use aqueous sodium hydroxide, so I don't need the anhydrous THF. So here I'm adding around 1 milliliter or a little bit more, it's fine, THF, tetrahydrofuran, in the vial, and I'm shaking it to dissolve my compound in THF. Once it is dissolved, then I will put back in the ice. Then I'll take 1 molar sodium hydroxide solution, pre-made, like I made it before. So 1 molar sodium hydroxide solution, and this scale is around 100 milligram scale. So I'm going to use 0.1 milliliter or 100 microliter of the 1 molar sodium aqueous sodium hydroxide solution, and I will add it while the vial is in the ice. So after addition sodium hydroxide, I'll keep stirring for overnight at 0 degrees Celsius. So I'll keep this vial here, and we have the 0 degrees Celsius room, like where the temperature maintains 0 degrees Celsius all time. So here is the room, and this room has the cooling system. So here I'm just transferring my vial from ice bath to another ice bath in a stirring plate so that it can stir. So this is the reaction setup, and workup is very easy. So if you like my video, share it and comment or ask any question, and subscribe my channel. And whoever already have subscribed, thank you for support my channel. Bye now.